Hello, today I will be talking about counters. The first type is ripple counters. We'll talk about it later. Let's go ahead with it. So, let's have a look at how or what is counters. Okay, so counters are circuits. Obviously there will be flip-flops in counters, and one of the most important thing about counter is that they will follow a prescribed sequence. Okay, so that is the main part of the counter. So it is right here, I have marked it for you guys. It will follow a prescribed sequence, okay, upon the application of clock pulse. Okay, so counters are of two types. One is the ripple counter, which I'm going to talk about right now, and another one is synchronous counters. So the difference between ripple counters and synchronous counters is that ripple counters don't have a common clock source, whereas synchronous counters do have a common clock source. Okay, so here it is written, you can see this, that the ripple counters flip-flop output transition serves as a source for the triggering other flip-flop, right? And whereas for synchronous counters, all flip-flops are triggered by the common clock. So that is the basic difference, that in synchronous circuits you'll have something like this. Say for example, this is there are some D flip-flops. I'm talking about synchronous. So there is this clock button, okay, clock signal. So all clock signal will be shorted, okay, and will be connected to a single clock source that will be, say for example, known as clock. So this is your example of synchronous circuit, but in the case of ripple counters this won't be happening. Okay, so let's move on to the first topic. I'll start with a very simple example, very simple ripple counter, or it is also known as asynchronous counter. Okay, it is also known as asynchronous counter. Okay, so let's talk about a little bit about the asynchronous counter or ripple counter. I'm going to give you an example of a simple 2-bit counter. Okay, a simple 2-bit counter. So let's talk about a simple 2-bit counter. 2-bit counter. Okay, 2-bit counter. Let's talk about it. Say I'm going to draw it for you guys. So I'm taking two T flip-flops. These are all T flip-flop. Just remind this, these are all T flip-flops. So this is, I'm taking this as a negative age triggered T flip-flop. Okay, so these are the outputs, these are the inputs. Now what I'm going to do is I'm shorting the input signals, both the input signals are shorted and connected with logic 1. Okay, and what I'm doing right now is at the first clock I'm just giving a major clock signal. Okay, at the first flip-flop clock signal I'm giving a main clock signal, but the difference is here. Just see this, what was it, it was mentioned there that flip-flop output transition serves as a source for triggering other flip-flop. Okay, so now for the second flip-flop right here, you see this clock will be connected with this output of the first flip-flop. So the second flip-flop's clock is triggered by the output of the previous flip-flop. That is a basic definition of asynchronous or ripple counter. Okay, so now let's talk about more about this, how it functions. So for example, there are two flip-flops. I'm calling it as Q0 and this is as Q1. Okay, okay, let's try to understand what is it and how it is actually operating. Say consider, so this is a basic 2-bit counter. Okay, first of all it's a basic 2-bit counter. Okay, So what I have done so far is I have taken two T flip-flops and I made the inputs short and connected with logic 1. And I have applied a clock signal at the first flip-flop, but in the second flip-flop's clock signal I inserted the first flip-flop's output. Okay, so this is what is happening. So q0 and q1 are my two output points. Okay, let's see. The clock signal generally is something like this. Basically it's a square wave, you all know it by now. Okay, so I need to draw q0 basically and q1. Okay, these are the targets I'm targeting to draw these two things actually. So see that I have taken the all the flip-flops to be as negative edge triggered, so I'm drawing the negative edges to draw the output basically. So if you have known about the T flip-flop, that is, if you give an input of 1 at the T flip-flop, your output will always toggle. For instance, say the current output is 0. If you have 1 as an input to the T flip-flop, in the next clock age the output will turn to 1. The next clock age it will turn to 0 again, and so on. So 0 1 0 1 0 1, it will keep on toggling till the as you have 1 in your in your input. Okay, so that's the main thing. So let's try to draw this right now. So considering that my initial output at q0 is 0, so it was 0. So let's this will help us to draw the output basically. Okay, so initial output at q0 is 0. Now at this negative edge right here, it will toggle as my input is 1. It will toggle to 1, and it will remain 1 till the next clock age, and then again my input is 1, so it will toggle again and back to 0. Then again at the next clock age it will toggle to 1. Okay, and so on. So you can easily understand. So what is happening? So I understand that the thing that is happening at q0 is a basic application or working principle of T flip-flop. Now what is happening at the next flip-flop, the second one? What is happening there? So see that this flip-flop's clock is actually triggered by the first flip-flop's output, that is q0. So for q1, q0 will be serving as clock signal. So this is my clock signal right now, right, for the next one. So I'm marking the negative edge because it's a negative as flip-flop, you can see that. So the negative is this one, and there will be another negative edge, right? Okay, so again I'm considering that the output at the initial output at q1 is 0. So it's 0, so it is something like this. So no clock right now, so there is a positive edge, negative edge, so it will toggle, and so on, so on, so on, until this one, then again it will toggle, and so on. Okay, whatever. So if I now write the values, so it is 0, it is 1, it is 1, it is 1, it is 0, and it's 1. Now if you see that I'm taking q1 as my MSB, okay, and definitely q0 as my LSB, you can easily understand. So now if I write it in a different position, and let's try to see what is happening. q1, q0, so the initial value was 0 0. If you read 0 0, then it was 0 1, that it is 1 0, and finally 1 1, right? So you see this is nothing but 0 in decimal, this is 1 in decimal, this is 2 in decimal, this is 3 in decimal. So the clock is counting in ascending order, right? So it is known as up counter, it is known as up counter. Okay, so it is counting in the upward direction basically. Okay, so there you have it. So it's a basic simple 2-bit counter. The working principle is something like this. Now if you want to change this counter and want to design a down counter, So how can you do that? Let me show. It is very simple. You can do it by yourself. I would suggest you do it by yourself. So I erase all the things now. uh, so our up counter is done, the ascending order counter or up counter is done. Let me just give you a homework basically. So how you will actually design a down counter. Okay, so how you are going to design a down counter, so that's the main thing, how you are going to design the down counter. So so see that. So this was my flip-flop again. Okay, so just this. So there you have it, you have a down counter. You basically, I what I did is I just changed the type of the flip-flop. So previously I took negative edge triggered flip-flop, now I'm taking positive edge triggered flip-flop. So this will change the counting sequence, it will now count in the opposite direction. So you may find something like this. Say for example, your if your initial state is something like this, 0 0, the next state you will be finding that is something like this, 1 1. Okay, and the next state maybe you'll find something like this. Okay, 1 0. And the next state you may find something like this, 0 1. And then again this is this. So the sequence is altered. So this was 0, this is 3, this is 2, this is 1. So it is moving in the downward direction, right? So that's why it is known as down counter. So I urge you, I request you to draw the wave shapes for this 2-bit circuit. Is very simple, and try to figure it out how it is actually counting in the downward direction that I have shown you right here. Okay, and if you have any question, please leave a comment. I will try to answer the question. Thank you.